So now it's saying assume we have to prove that the length angle definition is the cross product, that the cross products are distributive when the three vectors are coplanar. Right? So that means if you have, that means he's saying indirectly, you have to prove that A, distributive, that means we can distribute it, yeah? So if you have three vectors, A, B, and C, that lie in the same plane, coplanar, right?
Right.
That if you have A cross B cross C, that is the same exact thing as A cross B right?
Right.
A cross B
Cross with C.
Yeah, crossed with C. No, that's associative. That is associative, crossed with C. What's distributive?
Oh, right. That's A cross B.
That means, wait, that means if these are added, you can actually,
Yeah.
or subtracted, you could actually distribute the cross product.
Right,
So
right.
this can become
Right.
A cross B plus A cross C. That's what it means.
Yeah.
And the question is to prove this. Hmm?
All right.
The question, of course, is to prove this. Okay, well, if they're coplanar, let's just say that A is A1, A2, right? And some Z. If they're coplanar, they have to share one coordinate, no?
Right. Yeah.
We can make it 0 if you want.
Well, it doesn't matter. It can be. It's just a constant.
Right, and then vector B would be B1, B2,
And Z.
and Z. And vector C would be C1, C2, and Z. This means that the three vectors are coplanar, right?
Right.
They lie in the same plane. Okay, well, we can do the cross. We can start with the left-hand side. So the left-hand side, LHS. What's B plus C? You just add the components. B1 plus C1, right?
Right.
B2 plus C2, and 2Z. And now we will do A cross B plus C. You remember how to do cross product?
Yeah. It's just the.
So I, J, K. So A is A1, A2, Z. And this is B1 plus C1, B2 plus C2, 2Z. And you take the determinant of this, yeah?
Right.
So we start with the I component. So we hide the ith column and the ith row.
Right.
we hide the ith column and the ith row. And if we do that, if we hide the ith row, we will get and then so what we get is we get these, right? And you just cross multiply these. So you get 2a2 z minus b2 plus c2 times z. That's the I component. Yeah. And then we'll go to the j component. Excuse me. Minus j. And now you hide the jth column and the jth row. So if you do that, you'd hide this and this, right? So what you get is this and this. So you get 2a1z minus b1 plus c1 z. Okay? And then the last one is the kth component. So let's erase this. So now you hide the kth column and the kth row. And if we do that, so we can hide this and this, and we get this guy here, yeah? So this is a1 into b2 plus c2 minus a2 into b1 plus c1. This is all the kth component. Okay, let's massage this a bit. So we get 2a2 minus b2 minus c2 all multiplied by z. I took this as a common denominator. Alrighty. And we could do the same exact thing with the other guy. Oh, wait. Yeah, with the other guy. So this is all the I here. Minus 2. Actually, why don't we bring the minus sign in? So this becomes a plus. So minus 2a1 plus b1 plus c1 times z. And that's the jth component. And then the last one is the k. So the k will be a1 b2 plus a1 c2 minus a2 b1 minus a2 c1, and this is all the k components. Okay, so this is the answer for the right hand side. Let's see if the for the left hand side, let's see if the right hand side will stand up to this. So we'll do a cross b and then we'll do a cross c and add them. So now we're gonna go to the right hand side. Right hand side. So a cross b. Let's do a cross b. So this is I, j, k, a1, a2, z, b1, b2, z. Straightforward. we do the same thing. So I'll rush with this since you know how to do the cross product. So we get A2Z minus B2Z, and that's the I component, right? Minus the J component will be A1Z minus B1Z, and then the K component will be A1B2 minus A2B1. Already? And now we will do A cross C. Now, if you think about it, with A cross C, the only thing that will happen, every B1 will replace with C1, and every B2 will replace with C2, and Z is the same. So we can actually just copy from here. Do you understand what I'm saying? So this will be A2Z minus C2Z I minus J A1Z minus, instead of the B1 C1 Z plus K into A1. Instead of the B2, we're going to do C2, and instead of the B1, we're going to do C1. Got it? So I'm sorry, this was A cross C, not B. Okay, and now we can add them up. So A cross B plus A cross C. So these are two vectors. We add them like we add vectors. So we will add the I component with the I component. And notice that Z is the same in both of them. So if we factor out the Z, we will get 2A2 minus B2 minus C2. Exactly the same exact thing as this component on the left-hand side. And that's the ith component. Let's go to the jth component. We're going to bring the plus sign in. So plus J. Again, Z is a common factor. So let's just leave Z out. So we will have minus 2A2 minus B1 minus C1 J. Oh, minus minus becomes plus, right? These are plus because you have a minus here and a minus here. Yeah. So, okay, good. And if you look at the second, the y component, it's the same, minus 2A1 plus B1 plus C1 Z. So this checks and this checks. Let's go to the third one. Plus. So now K. So we have A1B2 minus A2B1 plus A1. So I'm adding the two Z components. A1C2 minus A2C1. And this is all the K component. And if we look, A1B1, A1C2, A1B, A1B2, A1C2, all good. And then we have minus A2B1, minus A2B1, and minus A2C1. Bingo. So this guy in red is, oops, I need to close it. This guy in red is the same exact thing as this guy in black, which proves that the right-hand side is equal to the left-hand side, no? LHS equals RHS. Therefore, it's definitely distributive. Therefore, A cross B plus C is indeed equals to A cross B plus A cross C, provided that the vectors lie in the same plane, coplanar. So we've proved that explicitly. Questions on that one? That concludes this proof.